I think. Yeah, we're live, we're recording. Okay, so review day 4, 18, 19. Okay, so right off the bat, direct, inverse, or neither, right? So direct is going to be, hopefully you know, it's like a y equals some mx plus 0. It has to be, right? Inverse is some x, y equals some number, okay? And neither is going to be neither one of those two, right? Does that make sense? So, number one, it's got to be inverse variation. X, y equals number. So this one's got to be inverse. Number two, it'd be great if it was 0 here, but it's not. It goes through 3. It has to go through the origin. So this one's neither. Right? And then y equals 1/2 x. Well, that's going to be direct variation because you've got a plus here. It goes through the origin. So this one's going to be direct. Okay, now, on 4, let's see what's going on with 4. So, first of all, first thing I like to check is this. 1 times 2, 2 times 4, it's not the same number, right? So it's not x times y equals number, so it is not an inverse variation. So then another thing I could do is, if I'm not sure, I could check, I could try and graph it. If I do just a real quick graph of this, just to see, I've got 2, 1, 4, 2, 8, 3. Let's see. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. Oh, and then 16, 4. Looks like it's going to start to curve, doesn't it? Doesn't look like it's going to start to curve. So, it's neither, right? It's neither. And then on 5, I think I've got the same number. 1 times negative 8 is negative 8. 2 times negative 4 is negative 8. 4 times negative 2 is negative 8. So it seems to me like it's x times y equals negative 8. That makes sense to me. So I'm going to say this one's an inverse variation. Okay, thumbs up. That's not too bad. Worst case on these, just graph them. Because sometimes it's hard to tell which one it is, but if you graph it, and if it doesn't look like a straight line going through the origin, it's going to be neither. Okay? All right, shift it up. Number 6. All right? The variables x and y vary inversely, so I'm going to say x times y equals some number, which is negative 15. Totally right, negative 15. So it says write an equation. There's my equation, right? And then find y when x is negative 4. So I'm going to go negative 4 times y equals negative 15. Divide. What's 15 divided by 4? What is that? 3 and 3/4. So 3.75. 3 and 3/4, I think. Thumbs up? Okay, now on the next ones, I'm probably going to need to put the next ones probably on a separate sheet of paper, okay? So let's take a look at 7. And if you can't see the screen, let me know, okay? 7, I've got a x squared plus a 5x over an x squared plus 10x plus 25. Okay, Kylie, do not cancel x squareds. Don't. Because it really has to be x squared plus 5x. So what we're going to do is factor, okay? You have to factor. So if I factor it, I'm going to factor this one into an x times an x plus 5. I'm just going to common factor. And then I'm going to factor this one into an x plus 5 times an x plus 5. Now I can cancel because we're multiplying, right? So we're multiplying, so I can cancel an x plus 5 over an x plus 5, okay? And what I'm left with is x over x plus 5, okay? Don't forget about common factoring. It's the easiest of them all, but you guys always tend to forget about common factor, okay? All right, number 8. If I get going too fast, please say slow down, Mr. Davies. Number 8, 12y over 6x to the 7 times 4x to the 5th over 8y to the 4th. Okay, so anything on top with anything on the bottom, right? Cancel. So 12 and 6. How about a 2 and a 1, right? 4 and 8. How about a 1 and a 2, okay? X7, X5. So 5 of these x's will cancel 5 of these x's, right? 5 of these We'll cancel 5 of these and leave you with an x squared. Y and y4, right? So one of these y's will cancel one of these y's and be left with y3. Okay, now, I can even do one more thing. Do you guys see one more thing I can do? Okay.
You lost me after you started canceling that x and y.
Okay, so let me rewrite this. If I had x to the 5th over x to the 7th, just what would this be?
X to the 2.
On the bottom, right? And that's what I did, but I just did it across. Does that make sense? The same thing with the y's. Did the same thing on the y's. I had a y over a y to the 4, don't I? Right here and here?
Yeah.
Which would make a y to the 3, but on the bottom. So I did the same thing, but just across each other, okay? Now, do you see one more thing? Do you see the 2's?
Yep.
Okay, so I have 2 over 2, right? So I could cancel that. I could cancel a 2 over 2. What's left over? Well, let's see. There's a 1 on top, right? And there is an x squared y cubed. And then if I look at my answer, I don't see anything else that can cancel. Do you guys agree? So done. Now, another way to do it if this really confuses you is just to multiply straight across. Multiply straight across and get one big answer over another big answer and then cancel from there. That helps. Does that make sense? If you want to multiply straight across, and then cancel. I like to cross reduce because for me it's faster. Okay. It was fast. 9. Let's take a look at 9. I've got a 2x squared plus a 2x over an x squared minus 3x times x squared minus x minus 6 over x squared plus 2x plus 1. Okay, now, factor. Okay, so I'm going to factor. I'm going to common factor the first fraction. I'm going to take out a 2 and an x, because that's what they have in common. Am I going too fast?
Yeah.
Okay. Okay. Yep. Totally agree. So I'm going to common factor out an x, but first let's take out a 2x. I'll have an x plus 1, right? Denominator, I agree, Daisy. Let's take out an x, and we will cancel. You're totally correct. I'll do that in a second. I'll have an x minus 3 times, okay, over here, its numerator in the second fraction will be an x minus 3, x plus 2. You okay with that? And on this one, let's make it an x plus 1 times an x plus 1, okay? So anything on the top is fair game with anything on the bottom. So let's see. Got an, like you said, Daisy, x over x. And how about an x plus 1 here, all the way with an x plus 1 here. Anything on the top is, because we're dividing, right? X minus 3 with an x minus 3, and then what I'm left with is still a 2. So I have a 2 and an x plus 2 over an x plus 1. Okay. Thumbs up? Okay. And turn the page. Look, did I go too fast? Okay, turn the page. Turn my page. Number 11. Okay, let's see what we got. 10. Number 10. Thank you very much. Thank you very much. 5x squared, 7y squared divided by 15x squared over 35y cubed. Okay, I'm dividing, so I'm going to flip. We're going to flip this fraction, okay? The fancy math way is we say we invert and multiply. Ooh. All right, let's do that. 5x squared over a 7y squared times 35y cubed over a 15x squared. Okay, Daisy, we're going to get another chance at practicing this, right? So here we go. Now we're going to multiply, right? So you invert and multiply. So flip it and then multiply. Okay, now anything on top is fair game with anything at the bottom. So x squared. You guys agree with that? Get rid of that. Let's see, I've got 5 and a 15, so why don't I make that a 1 and a 3, right? A 7 and a 35, how about a 1 and a 5, right? Right? How about a 1 and a 5? Y squared, y cubed. Okay, Daisy, you see it? Y squared, y cubed. 2 of these cancel with 2 of those, so then I'm just left with a plain old y. Okay, so what's left over? Well, on top, I'd have a 1 times 5, 1 times 5, or a 5y, and on the bottom, I just think I have a 3, that's all. You can do this tomorrow, can't you? Just take your time and be careful. Just take your time, be careful. Yes?
Oh, so the first equation turns into 1 because dividing, canceling out the exponents and all that.
Yeah.
Okay.
Yeah. Yeah, and if that confuses you, my cross, this is what I told Daisy. You can multiply straight across, get a big, ugly answer, multiply straight across, and then reduce from there. If this cross simplification bothers you, multiply, and then cancel, okay?
Okay.
It'll work. I like to cross cancel first because it makes the problem easier for me. I don't have to deal with big numbers. How about number 11 now, huh? 2x squared plus 5x plus 2 over x squared minus x minus 6 divided by x squared plus 3x minus 10 over x squared plus 2x minus 15. Okay, so same thing, I'm dividing, right? So if I'm dividing, I'm going to flip this one, okay? Invert and multiply, that's the math term for it. So let me go ahead and rewrite this. I'll have a 2x squared plus a 5x plus a 2 over an x squared minus x minus 6 times, right? Times an x squared plus 2x minus 15 over an x squared plus 3x minus 10. Okay, now, factor, 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 right? We're going to factor, 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 factor. So, to factor 2x plus 5x plus 2, I think it's 2x, x, yes, plus 1 and plus 2, because I get my 4, my double, remember your double smiley? Remember your double smiley? There's my 4, and my 1 makes my 5x, right? Yeah. I will slow down. Thanks, Olivia. I will slow down for you, okay? Yep. So I factored the first one, and you give me thumbs up when you're ready for me to keep factoring, okay? So I'm going to factor, 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 factor. Then I'm going to have fun and cancel, 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 cancel. Okay, Olivia? So let's factor x squared minus 1x minus 6 into an x minus 3 times an x plus 2, okay? And I can already see something I can cancel, right? Times, all right, x squared plus 2x minus 15 factors into an x plus 5 and an x minus 3, right? And then if I factor x squared plus 3x minus 10, I think this factors into an x plus 5 and an x minus 2, right? Okay, here comes the fun part.
X minus.
Let's cancel. Let's cancel an x plus 5 with an x plus 5, right? An x plus 2 with an x plus 2. An x minus 3 with an x minus 3. And what I'm left with is a 2x plus 1 over an x minus 2. Okay, thumbs up. All right. Olivia, thumbs up.
1 second.
Okay,
Hold
1
on.
second. Oh, okay, I'm waiting. Okay.
Could you cancel out those?
No, don't do that.
No, I mean like they have to have the exact same sign and everything. Like,
Everything's got to be the same.
All right.
Okay.
So
Now let me show you an example on the side. Just want you to watch this, okay? Okay, you watching? If I had 7 plus 3 over 7 minus 3, right? It should be, the answer should be 10 over 4, right? Shouldn't be, you agree with that?
yeah.
But what if you cancel the 7s and you cancel the 3s? Will you get the same answer?
No.
No, so don't do that because it really isn't 7 plus 3, it really is 10, isn't it? It isn't 7 plus 3, it really is 10. And the same thing here, this is really an x plus 2. It's not an x, it's an x plus 2. Okay? Does that help show you why?
They don't they show why.
Okay, let's do 12. All right, number 12. I have an x minus 3 over a 2x plus 1 minus x plus 9 over 2x plus 1. On this one, you have to be extra careful about the negative. You really do. So what's my common denominator? Well, it's easy. I already have one, right? I'm subtracting. Have to have a common denominator, okay? So I have a 2x plus 1. Now in the numerator, be careful to subtract. I'm going to go an x minus an x, right? In fact, I'll even do it this way. I'm going to go x minus 3 minus an x plus 9. I'll show it long ways, okay? I'm really subtracting this expression, okay? We got to be careful of the negative because the negative is going to come through, right? Got to be careful of the negative. So 2x plus 1 over an x minus 3 times minus, and I get a minus x and a minus 9. You see the minus 9? Everybody okay with the minus 9? Subtract a 9, right? That's where you're going to make a mistake if you're not careful with this negative, okay? Because you're subtracting both, okay? So x's cancel. I'm left with a negative 12 over a 2x plus 1. And that's all I can do. Can't do anything else. Now, I took a lot of time to show that. You could probably shortcut that. If you're careful with the negative, you can probably shortcut this significantly, okay? 13, are you having fun? Oh, yeah. 5x over an x plus 2 plus an x plus 12 over an x plus 2. Okay? Do they have a common denominator? Yeah, of course they do. X plus 2. And on the numerator, let's get a 6x plus 12. Now, there's more we can do. Yeah, let's factor. So let's factor and see what happens. So if I factor, I'm going to get a 6 times an x plus 2 over an x plus 2. Hey, sweet. Cancel, and it's just 6. Got it? Okay, I'll whisk this. I'm going to turn my page when you're ready. I will. I'm going to flip this page when you're ready. I'll wait for you. 14. All right, 14. I'm going to probably have to factor. It's okay. I don't mind factoring. X squared plus 2x over x squared plus 5x plus 6 minus a 1 over an x plus 3. So to subtract, I need a common denominator. Okay. So what I'm going to do is factor this one. This one factors into a x plus 2, x plus 3. Okay. So if I factor x squared plus 5x plus 6, it factors into an x plus 2, x plus 3. You guys agree with that? So let's look at our common denominator. So what does this second fraction need to have a common denominator? It needs an x plus 2, right? So let's make sure it gets an x plus 2. X plus 2 over x plus 2. Okay, so then from there I have my common denominator. So I'm just going to go ahead and write it down. My common denominator is my x plus 2 over my x plus 3, right? That's my common denominator. So in the numerator, let's do some, got to be careful of the negative. Again, I got to be careful of that darn negative, but I'll get there in a second. The numerator, I'm going to have an x squared plus 2x. But then, I'm going to think of this as a negative 1. I'm going to go negative 1x and a negative 2. You guys okay with the negative 2? You see where I got the negative 2 from?
Do you not factor the first equation?
Don't. Great question. Don't. Really, I'm really glad you brought that up, Saul. You can see that it can be factored, but what you have to do, Saul, is this step right here, you have to be able to add them, right? Or subtract them, right? And you can't. If you had factored it, you wouldn't be able to subtract, right? Okay, I'm glad you brought that up. So then, let's see what I have. An x squared plus a 1x minus 2 over an x plus 2, x plus 3. Okay, great. Now, do you see anything else maybe we could do? Yeah, let's factor. So if I factor this one, now I want to factor. Do you see why, Saul? I don't need to add anymore. I'm just going to factor. X plus 2 times x minus 1 over x plus 2 times x plus 3. And then we can reduce. We can reduce because I can cancel out the x plus 2, and I'll be left with an x minus 1 over an x plus 3. Okay? You can do this tomorrow, can't you? Yeah, Joanna.
From the beginning, couldn't you have crossed out x plus 2 from the top and x plus 2 from the bottom?
Actually, that might have worked.
Because you did a factor on the top from the
That would have worked. I didn't see that. Yes. I didn't see that.
faster.
That would have been way faster. Thank you. Absolutely. I'm bummed I didn't see that, Joanna. Good for you. So she said, couldn't you factor off the beginning and then something would have canceled? And it would have made the problem much easier. Yes. Nicely said. Okay, you guys ready for 15? Okay, whisk this away. Okay. Okay, 15 is going to be easy. 15's easy. I've got a negative 1 over x equals x plus 2 over 1. Now, I don't need to put the 1 there. I did just to help us out. How about cross multiply? Cross multiply, right? So I'm going to have a negative 1 equals x times x plus 2, right?
Yeah.
Negative 1 equals x squared plus 2x, right? Bring over the 1. Let's add the 1. Let's bring the 1 over to here, right? So let's bring over the 1. 0 equals x squared plus 2x plus 1. I think it'll factor, won't it?
Plus 1 is plus 1.
Yeah, x plus 1, x plus 1, or x equals negative 1, right? Now, negative 1's okay. What I couldn't have is an answer of 0.
Yeah.
You with me? Negative 1's okay. I cannot have a 0, right? So I'll keep that answer. How am I doing? Terrible. Okay, 16. I have a negative 2x over an x plus 2 plus an x over 3 equals a 4 over an x plus 2. And I left lots of space on purpose because I'm going to need a common denominator, right? So I'm going to need a common denominator. How about multiply this one by 3 over 3. Multiply this one by an x plus 2 over an x plus 2. Multiply this one by a 3 over a 3. How am I doing? Common denominator. All right, let's see what I have. So my common denominator is going to be this. A 3 times an x plus 2. My common denominator here is a 3 times an x plus 2, okay? My numerator is going to give me a negative 6x plus x squared plus 2x, okay? So I'm multiplied here to get negative 6x. I multiplied x times x plus 2, and I got x squared plus 2x. And then over here I'll have a 12, okay? Now, I can just get rid of the denominators. You guys agree? I mean, I can multiply both by 3 times x plus 2 on both sides, 3 times x plus 2 on both sides, 3 times x plus 2 on both sides. So
Copy in negative 4x in negative 6x plus x to the second power plus 2x would not be.
oh, I think it's just an x squared plus 2x here, isn't it? Oh, when I simplify, yes, you're ahead of me. Daisy, you're ahead of me. We're going to do that. Yeah, I know what yes. It is going to be an x squared minus a 4x. Yes, equals 12. Okay, I guess I don't need that fraction line anymore. Daisy, yes. Okay, so then I'm probably going to factor, so I'll bring the 12 over. Okay, x squared minus 4x minus 12 equals 0. Okay, factor. How about a 6 and a 2? 6 and a 2. How about a negative 6, positive 2? Negative 6, positive 2, right?
So that would be negative 2 positive 6.
Yeah, negative 2 and positive 6, right? Oh, but Calvin said, wait. Calvin says you can't use the negative 2. How come?
Because
If you put it right up there,
equation.
you'll make Cookie Monster sad, won't you? You'll divide by 0. Can't do that. All right, you guys ready? I'll wait for you. We're getting there. We're very close. We got 5 minutes to get this done, but we're going to get it done, okay? Graph's not so bad. And then if I don't get to the story problem, you guys, we just did that one, right? Kind of like it. It said Beth and Tom. It was Cole and Saul, right? Yeah. Okay, whisk this away. You guys got it? Okay, number 17. All right, so I have to graph this. Okay, before I do anything on 17, f of x is equal to x plus 5 over x squared plus 3x minus 10. So let's factor. Let's factor. So I'm going to have an x plus 5 over an x plus 5 and an x minus 2. Okay, so I like the way Ashley said it. Ashley, you said it so well. So x cannot equal negative 5, but that one's removable, right? That one's removable. Since it's removable, that's where my hole is. Okay, that's my hole. And x cannot equal 2. So that one's non-removable, so that has to be a vertical asymptote. Okay? So if I simplify it, I'll have 1 over x minus 2, right? If I just simplify here to here. And now I can plug in negative 5. I really can, because I won't have a problem if I plug in negative 5. So if I do f of negative 5, I get 1 over negative 5 minus 2, which is negative 1/7. Okay, so if I can plug in negative 5 now, right, without a problem, because I removed the problem. So my hole is at the coordinate of negative 5, negative 1/7. And then my vertical asymptote is at x equals 2. Now, I haven't even touched the calculator yet, right? I haven't even done it. I don't even need the calculator, but let me go ahead then and start to graph it. Okay, let's see if I can find a ruler. Here we go. So, I don't need a ruler. I mean, I don't need a calculator. I can do this without a calculator because I'm smart. Semi-smart, huh?
Yeah.
Kind of blew that one problem today, but I'll come back and fix that one, okay? So before I do anything, I know for sure at positive 2 have a vertical asymptote, right? I know at negative 5, 1, 2, 3, 4, 5, and negative 1/7 I have a hole, okay? I know the graph has to go through at negative 1/2. How do I know the graph has to go through at negative 1/2? Well, let's go to the original problem. If x is 0, what do you get? If x is 0, what do you get? If x is 0, don't you get 5 over negative 10? So the y-intercept has to be there. So my graph looks like this. And I'm going to put it in my calculator if you don't believe me. And it takes a dive. And then the other half of the graph is over here, okay? And you can put it on your calculator if you don't believe me, but that is it. Okay, and the only problem I didn't get to is the work problem, which I will do just for Evan and Morgan so they can see it. If the bell rings, you guys just go ahead and go, but I'm going to do number 18. I'm going to do number 18 here. All right, so I got Beth and I've got Tom. Okay? So Beth can tell 4 in 10 hours. So Beth can do the job in 10 hours. But if she works with
I
Tom,
wish it was less forgiving. Just let you insta-die.
they don't know how long Tom can do. But together, it takes them 5.8 hours together. If I add their work, Beth's time, Tom's time, but if I add their work, it's 5.8 hours to get the one job done. Always one. Okay? Now, let's solve it. Common denominator, x over x, 10 over 10, 5.8, x over 10x plus 58 over 10x equals 1. I'll have 5.8x plus 58 over 10x equals 1. I'll keep solving. I'll multiply up to 10x. I'm still going. You guys are watching though. Why not, right?
Mr. Davis, have a nice day. Wait,
I will.
your calculator?
Yeah. Okay, gotcha. Multiply by 10x. Multiply it up. Minus 5.8x minus 5.8x. How am I doing? 58 equals, what's that, a 4.2? Probably 4.2x. Divide, what's 58? What is 58 divided by 4.2? Divide by 4.2, 4.2. And I get about 13.8 hours for Tom. There we go. Ta-da! We got it done. Gotcha. Thank you, guys.